Hi, Roger McGool is here, Vice President of Radar at O'Reilly at the Software Architecture Conference in New York 2019. I'm here with James Bottomley. He's a distinguished engineer at IBM. So why don't you say a little about who you are and what you're working on?
Yes, certainly. So I'm a distinguished engineer at IBM Research. And my main topic of research is actually the fundamentals of containers, and specifically Linux containers. So my background is actually as a kernel coder. For a long time, I was actually maintainer of several subsystems inside the Linux kernel. And in 2011, I joined a container company called Parallels, and it was my job to get their container technology, or as close an approximation as we could, upstream into the Linux kernel. So from 2011 through to the present day, I spent my time working on the containerization primitives that we actually have in the Linux kernel, and which in 2013, 2014 enabled the Docker revolution in DevOps and all the other goodness that people at this conference are actually talking about.
It seems to be the foundation of what it takes to make the kind of modern architectures work, is that containers are something you can deploy easily and everywhere.
Yes, so I was going to talk about that. I had this wonderful talk lined up for this conference because I don't usually get to talk at high-level conferences. Being somebody who really works on the low-level primitives, things like namespaces and C groups are what I work with, and that's not really what anybody wants to hear about at an architecture conference. I don't often get let out of the box to come here, but I thought it would be nice to give a nice overview in architectural terms of how the infrastructure paradigms, like going from physical systems to virtual systems to containers, have actually driven all of the changes in the way we actually do stuff in industry today. Going from having to sort of deployment systems through the sort of deployment scripts like Ansible, Puppet, Chef, the new stuff, then trying to get onto DevOps and immutable infrastructure and everything else. And so I was building up this wonderful talk about how all the infrastructure people essentially invent the paradigms and make them easy for the architecture people to use and consume. I actually realized that we had a missing infrastructure paradigm in containers, which means that a lot of the DevOps assumptions that people make use of and claim are properties of container aren't actually properties we're exporting from the underlying container technology. And for some of them, they're not even properties that are enforced anywhere in the ecosystem. This actually leads to a somewhat interesting architectural imbalance, which I'll also be talking about as part of the DevOps cycle.
Can you go a little deeper? I have a guess at what you're talking about, but maybe you can...
Yeah, sure. So the DevOps cycle is based on this idea that you can precisely, using container technologies, you can precisely transport the environment you develop the application on into a test environment that you've constructed, and then precisely transport the same thing into the cloud where it will emit its services. And the precision of the transport is such that the testing you did on whatever infrastructure you had in your test suite should be as valid as if you'd done it on the cloud. And this precise transport depends on something called immutable infrastructure. The idea that the infrastructural paradigms you make use of, that even you don't think you're making use of in your dev test environment, are precisely the same as the ones you'll see when you deploy in the cloud. And this infrastructural paradigm, immutable infrastructure, is often thought to be a property of containers, and I was actually going to tout it as a property of containers when I gave my talk. And when I actually thought about it, after writing the slides, I actually thought about what I'd said, and I thought, there's nothing in container technology that actually enforces this immutability. Is this really an architectural property of anything in the system? And it turns out it isn't. And even worse than that, it turns out that a lot of people who pay lip service to producing containers through DevOps and actually upload their work to the Docker Hub, so I can just download it and pour through it and see what they've done, have violated this immutable infrastructure property. They're not following any of the DevOps things, and it turns out that about 60% of the containers you can get at the Docker Hub are not actually DevOps compliant in this way, which is an interesting statistic when you consider that we're all fired up about this DevOps revolution, microservices, and the fundamental thing that underpins it is something we don't have a guarantee for in the infrastructure, and in fact nothing enforces.
So you're bringing up kind of two vectors of discussion I would like to talk about. I'll start with the high-level thing, which is, what do you think about microservices and what's going on in that? Like, what is your sense of the adoption rate?
Well, so my sense of the adoption rate is that it depends how you count. So if you judge the adoption rate by the number of people paying lip service to using it, it's enormous. If you judge the adoption rate by the number of people actually deploying systems based on it, it's not so big. But the difference between the sort of the hype and the reality is always good in these sort of circumstances, because it means there are lots and lots of people scrambling to try and do this. And when I look at some of the paradigms I was going to talk about, if you think about the way we've been going from physical systems to virtual machines to containers to microservices and sort of script-based things like OpenWhisk and Amazon Lambda, what we've actually been doing is making our architectural components much smaller and much more triggerable. And this seems to be a sort of constant as we go up this. And the ability to put together pieces from this constant seems to be an excellent way of actually constructing in the cloud applications which have a reasonable chance of being sort of talking to the things they're supposed to talk to, being robust, and actually being able to produce things that require that you didn't have to have an entire team build this 1 million line code program. You just picked a grab bag of things off the internet, connected them with a few HTTP REST connectors, did your little scripty trigger, and had a front-end web page to get everybody to view it. And that seems to be a very simple way of actually bringing up incredibly complex services. So in IBM, we're looking at doing things like this for, say, AI, machine-assisted learning. If we can actually link a very simple trigger script and a sort of set of nice primitives to this, we can actually get something that will actually truly bring AI to whatever service you are actually trying to do. So in those terms, I think that the trend through to microservices is actually a trend basically, I mean, it's had many names. So we call it microservices today. It wouldn't have been incorrect, 10 years ago to have called it a mashup. In some ways, the same principles are exactly what we're using in the same thing and the same ideas. I don't want to build all this stuff myself. I want to take all the stuff you've put together, take your self-describing endpoints and consume them very easily into something I then make a ton of money on selling as a service to the consumers. So yes, I think microservices are a good trend, and they're definitely here to stay.
So you brought up Lambda, and the other vector I want to just ask quickly about is this around serverless and that type of thing. You mentioned immutable infrastructures. What do you think about serverless and where we're at?
I think architecturally, the trends going from physical to virtual. So when you went from physical to virtual, you tried to free yourself from some of the stuff you have to do in deploying a virtual machine, like knowing what all the drivers are and all of the weird installation tricks you had to do. Now, this promise didn't quite live up to it for virtual images. So you probably know that an Amazon virtual image of AMI image can't necessarily be deployed in a VMware cloud because of the driver differences. So we have a problem there. Containers took that up another level. Actually, if you think about it, we took the interface from being real hardware in physical systems to being the virtual hardware interface in virtual machines to becoming the syscall interface in containers. So everything below the syscall interface, which includes the kernel and all its drivers, is now stuff I don't need to know what goes on where. This is what enabled the sort of the easy building of Docker images. Serverless is taking that a stage further, because now what it's trying to do is to say that the thing I want to containerize is really just this tiny script, and I'll tell you what language it's written in and what platform it needs to run on, but you, Mr. Cloud Service Person, just deploy that, and my script should run, and it should actually be transportable anywhere. Now that's the promise of serverless. In the same way as we promised immutable infrastructure for containers, I'm not saying we'll live up to it, but if we can realize some portion of that promise, what we get out of this is true application containers. Instead of, right at the moment, Docker containers, we call them application containers, but they're not, because they contain all of the infrastructure down from the application to the syscall level. And serverless offers us the possibility of ejecting all of that infrastructure. And when I say ejecting, I mean turning over management of that infrastructure to the cloud service provider, because this is basically all about enabling people to do the things they're best at. If I'm an architect building a container, I'm not best at constructing operating systems, and yet in every container sits a little operating system that somebody has to have constructed and that when I deploy I have to manage. Turning that over to the cloud service provider as serverless promises is actually the way of truly liberating ourselves and actually bringing application containers as a proper architectural construct instead of effectively what we have today, which is a mashup.
So what's kind of fascinating what you're talking about with serverless, when I think about serverless, is something someone told me a long time ago. Computers are terrible at doing nothing.
Yes, they are.
So the promise of serverless, in some ways, there's a great productivity thing that you're describing, but it also means with fast spin-up is that you can actually maybe turn computers off when you don't need them, that you're able to handle kind of variable loads and stuff. Do you think that that's something that is helping drive this, or is that too far off? Or
I think realistically the problem is the computer equivalent of Parkinson's law, which is basically programming always expands to fill the capacity available to it. So if you think of who will be running these little serverless scripts, they'll be running in a cloud service environment, and their job is basically, the job of the hardware will be to run as many of these scripts as possible. And right at the moment, it looks like the industry's appetite for doing stuff with compute exceeds our capacity to actually build compute systems. That's why if you look at sort of Google and Apple, their specialities are filling shipping containers with computers and dropping them in the desert because we physically can't get the computing power. So I think the idea that serverless is just so minute in computing power that we'd be able suddenly to switch off all these computers really won't fly. But what will happen is that it's a scaling problem. And actually, if you think about things like OpenStack that were originally designed to build and orchestrate virtual machines, they couldn't cope with the container world because they had a scaling problem. It turns out that the amount of memory something like OpenStack uses to manage a virtual machine is tiny compared to the virtual machine's memory footprint, but it's actually overwhelms the container's footprint. So if you bring something like OpenStack to manage containers, you expend most of your main memory of the system on the actual orchestration thing itself instead of the container you're supposed to be running. That's why Kubernetes effectively took over from OpenStack. Now, if you look at, and in fact, the scaling number you went from virtual machine images to container images was somewhere between 10 times and 100 times. And if you look at scriptless, we're trying to do the same thing again. Instead of wanting to run, 100 virtual machines on this, giving way to 5,000 containers, we'll want to run 50,000 to 100,000 of these little scriptlet things. So whatever we use to run them has got to be incredibly light in terms of its footprint. It's got to be incredibly agile, and it's got to be capable of scheduling, hundreds of thousands of these things in a second. And if we get that right, what we'll actually be using is the same physical infrastructure and probably quite a bit more of it, but they'll be whipping these things in and out as fast as they possibly can.
So it's like a density. You're going for density in a way. Density of compute.
Questing density of compute.
Yeah, great. Well, this is great. I wish we could continue the conversation. I'll bet your talk today is going to be great, but thanks a lot for your time today.
You're very welcome.